Before we start talking about dividing with polynomials, we want to take a moment to talk about negative exponents. So here's an example. If we start with repeated multiplication, we have 4 2's in the numerator, 7 in the denominator. 1, 2, 3, 4, 5, 6, 7. And because there's no adding and subtracting, we can divide our factors out. And we see that we have 3 2's left in the denominator. Now, we could also have used that quotient rule that says when you're dividing powers with the same base, keep the base and subtract the exponents. So we can see here that 2 to the power of -3 is equal to 1 over 2 cubed. So we have that rule that we were using that tells us keep the base and subtract the exponents, but we can also see that that negative exponent moved 2 to the power of 3 to the denominator. What it did not do is make our number negative. A negative exponent does not change the sign of the base. Just another reminder to all of you that you should have these notes printed out in front of you. And if you don't, you should be writing this all out so you have notes for your own review. So we say then if n is an integer greater than 0 and the base is a real number, if we have a to the power of -n, we can write this as 1 over a to the power of +n. In fact, a helpful way to think about this is that negative exponent is an F telling you to flip the expression. So if we look at this example here, we want to flip the expression. It becomes 1 over 3 cubed, which of course is 1 over 27. What about the next one? That negative exponent is telling us to flip, but be careful. What's the exponent on 2? 2 has an exponent of +1. So we don't want to move the factor of 2. 2 is going to stay in the numerator. We're only flipping or moving x to the power of 4. And then we've got these examples with a negative base with brackets and without brackets. Remember that negative exponent is telling us to flip the expression. It becomes 1 over, the base is in brackets, let's keep it in brackets. Notice that the base 2 is still negative, the exponent is now positive. What about this one? The exponent is negative. That tells us to flip it to the denominator. The base is not in brackets, so we're going to leave it just the way it's written. This is 1 over 16, but it remains negative. So be careful about those two. Remember that a negative exponent does not change the sign of the base. In our first example, we have a positive 1 over 16 because -2 multiplying itself 4 times is positive. Now, we know that 2 to the -4 equals 1 over 2 to the +4. So I could write this as 1 all over 1 over 2 to the power of 4. That's a complex fraction. It looks difficult, but we remember that this is division. 1 divided by 1 over 2 to the power of 4. And when we divide with fractions, we multiply by the reciprocal. Notice what happened here. When we had a negative exponent in the denominator, we flipped the fraction again and we moved it to the numerator, and the exponent became positive. We're only changing the sign of the exponent. So we can say, if we have a negative exponent in the denominator, move it to the numerator, flip the expression, and it becomes positive. Most of the time, you're going to be asked to write your expressions using positive exponents. Why don't you pause your video, try the first two. We have a negative exponent. We know we need to move that to the denominator. This simplifies to 1/16. There are two ways you could think about the second question. In the first one, we could use our exponent rule that says if we're dividing powers with the same base, subtract the exponents. And now that we have a negative exponent, we know that we need to flip it to the denominator. A second way to think about this question is to think about the expanded multiplication. We can see, even before we write this all out, that there are more x's in the denominator. In fact, I hope you could see that there would be 3 x's left in the denominator. Let's talk about the next two. I'm going to suggest that your first step should always be to make all exponents positive. You don't have to do it in this order, but I think that it's an easier way to think about it. People have difficulty with negative numbers, so let's make them positive. There's a -3. That tells us to flip that to the denominator. So we have 2 to the power of 5 times 2 to the power of 3, leaving 1 in the numerator. Now we can use our product rule, multiplying powers with the same base, keep the base, add the exponents. And I think we can evaluate this. 2 to the power of 8. Is it 256? I think so. You can tell me if that's wrong. What about the next one? Both exponents are negative. They both need to be flipped. So 5 to the exponent 1 moves to the numerator. 5 exponent 3 moves to the denominator. We can see there's more 5s in the denominator, 2 more. If you subtracted exponents, you would have seen that that was equal to 5 to the power of -2, which of course is then 1/5 squared. Pause your video, try the next two. We have a negative exponent here. We're going to move it to the numerator. That means there's 1 in the denominator, but we don't need to write the over 1. Keep the base, add the exponents. That simplifies to 81. Both exponents are negative. So we're going to flip both of them. Our bases are in brackets. Let's keep it there. We're not changing the sign of the base. We're only changing the sign of the exponents. There are more -3s in the numerator. Okay. Let's do this first one here together. Notice that we have 3 factors with base m. When we're finished, We want only one m in our simplified expression. If we're going to make all of our exponents positive, I can see I need to flip each of these at the denominator and move them to the numerator. So we have m cubed times m squared times m to the power of 4. Keep the base, add the exponents. Pause your video, try the next two. The negative exponent tells us we're going to flip each of those to the denominator. So now we have x to the power of 4 times x cubed times x to the power of 5, leaving 1 in the numerator. Keep your base, add the exponents. We're going to make our exponents positive. So in the numerator, that 2 to the power of 4 is going to be flipped up. In the denominator, we have 2 times 2 squared times 2 to the power of 5. We should simplify the denominator, keep the base, add the exponents. Remember, there's a power of 1 there. And now I can see there's more 2's in the denominator. 4 more. Or if you had subtracted exponents, 4 minus 8 is negative 4. This will be 1 over 16. Those can be difficult. So if you need to, rewind the video and watch this part again, try them again, think about what's happening with those negative exponents. There are different ways to think about these next few questions. One way is to take that negative outside the bracket and make it positive. In order to do that, we're going to take the entire base, all of this, and move it to the denominator. Notice that the exponent on y stays the same because that's part of the base. The only thing that's changing is the exponent outside the bracket. Now we're going to use that power of a product rule that tells us that that 3 applies to every factor inside the brackets. So we have 1 over negative 2 cubed, x cubed. And remember, we're multiplying exponents here. This will give us y to the power of negative 9. This negative exponent tells me I need to flip that back up to the numerator. Negative 2 cubed, that's a positive exponent. It's going to stay in the denominator, but I'm going to evaluate this. Negative 2 all cubed is negative 8, and the x cubed stays in the denominator. The only thing we're going to change here is that negative in front of the 8. We're going to write it outside of our expression. Don't leave your negative sign in the denominator. That was one way to think about this question. If you need to see that again, rewind the video and watch. I want to talk about a second way to think about it. The second way is to apply that power of a product rule first. That tells me that the negative 3 applies to every factor inside the brackets. So we have negative 2 raised to the power of negative 3, x raised to the power of negative 3, and y, well, we're multiplying exponents, becomes a positive 9. These two have negative exponents. We need to move them, flip them to the denominator. So only y to the power of 9 stays in the numerator. Now we have negative 2 to the power of positive 3 and x to the power of positive 3 in the denominator. Again, we can evaluate this. Negative 8, I'm going to put the negative outside the expression, x cubed. It doesn't matter which one of those you think about, whether you want to take this power and make it positive first, or apply it to everything inside the brackets and then make your exponents positive. Here are 2 more questions. Why don't you pause your video? 3 more? Yeah, pause your video, give these a try. Let's look at the first 2, and then I'll look at the last one with you. I applied that negative 1 to each factor inside the brackets. I can see that x has a negative exponent, so I'm going to leave y in the numerator. The exponent is positive. Move x. So I have a negative exponent in a couple of places. I'm going to move those. But first of all, let's leave y to the power of 9 in the numerator and y to the power of 1 in the denominator. And then I'm going to move that negative 2. I'll put that out in front. We always like our numbers in the front. Now the exponent is positive. I'm going to move that x to the power of 3. Now the exponent is positive. And x to the power of 1. I don't need to write that 1 necessarily. We still have some simplifying to do because there are 2 factors of y and there are 2 factors of x. We are not finished simplifying until we have just 1 factor with that base. So let's look at the negative 2 cubed. We already know that's negative 8, and it's going to stay in the denominator. That's where the exponent is positive. If we look at y next, I see there are more y's in the numerator. It's going to be y to the power of 8. There are 8 more there. There are more x's in the denominator. 2 more. Give this one a try if you haven't already done so. Again, I've applied the exponent outside the brackets to each factor inside. And now we see that we have some negative exponents that need to be flipped or moved. So that negative 3, I'm going to move it to the denominator, and now it has an exponent of positive 2. That negative 2, I'm going to move to the numerator, and now it has an exponent of positive 3. X to the 8 has a positive exponent, it can stay. X to the 9 has a positive exponent, it can stay. This y I can leave here, and this y I will move to the denominator and make the exponent positive. So negative 2 cubed is negative 8. Negative 3 all squared is positive 9. I see that there are more x's in the denominator, 1 more. And these y's, I can simply multiply the powers with the same base and add the exponents. These are difficult questions. They take a lot of practice, but it's useful to be good at those before we move into polynomial division.